Hi, welcome back to the CE371 Soils lab videos. Today we're doing lab number 6, the Unconfined compression test lab. And in this lab we're going to be testing the shear strength of clay. Let's dig in. So before we get started, we're going to go ahead and go through the equipment we're going to use for this lab. First off, we have our Harvard miniature mold. It's like the mold we used at several labs back, but miniature. As you can see right here, we have our wing nuts. We have our top collar right here. We have our mold right here. We have our base plate. So again, it's very similar to the previous molds we've been using, but just kind of sized down a little bit. Also, going off that is the Harvard miniature hammer right here. So in previous hammers, we've either had like something that we would drop, or we would raise something up in a metal shaft and drop. This one is more of you push on it until you break the spring. So it's not necessarily something that we're used to using. You're essentially putting this in the soil, just breaking the spring. You're gonna use it 25 times, 25 blows on the soil like we previously did. It's just a little bit different than what we're used to. It's spring powered rather than like gravity driven. Next we have our 2 pieces of filter paper, which we're gonna put this on our mold. More to follow on that in the lab. We have our teaspoon. This will be used for transferring the soil over to the mold, or getting bits of the sample out after we have performed tests on it and moving it to the tear can. Right here we have our ice pick for breaking up the mold and scarcifying the surface on different lifts when we put those in the Harvard miniature mold. We also have our saw. So just like on previous labs, when we have to essentially cut off like any excess on the mold in any excess of the sample in the mold, we use a saw to do so, to make sure that we have the exact volume, exact amount that we want. Next we have our digital calipers for measuring the length and the height of the mold. We also have our releasing agent. This will be used to spray inside the Harvard miniature mold, so then when we're pulling it out, we won't have to put too much elbow grease to use this guy to pop the mold out. Going off that, this is our device used to essentially pull the mold out of pull the sample out of the mold. So what you'll do is you'll have a two-person team right here, and Chris, if I could borrow you real quick. So you're gonna have 2 people real quick. You're gonna put the mold in here. There's a little bracket right there that you'll be able to see that you can put the bottom grooves of your mold in here. And you're gonna have one person who's gonna be pushing down like this, hopefully being able to easily pop the sample out of the mold. And while we're doing this, we don't want to not have anybody catch the mold, because if no one catches the mold, the mold's gonna fall down and potentially damage the sample. So we're gonna have a second person hold the spatula. They're gonna put it through the top right here. And essentially, they're gonna put the spatula at the bottom right here to catch the mold. So that way, when I push down and the mold pops out of the sample pops out of the mold, he's able to catch it with the spatula to make sure that it doesn't get damaged. Thanks, Chris. Appreciate it. Next up, we have our small scale. Don't know what that's used for. It's essentially measuring the weight of the sample. And then finally, we have our Unconfined compressing test machine right here. I don't know if y'all can see it. Let me move it a bit closer. And we'll talk about this a little bit more when we get into the lab on how to use this. But essentially, we have our certain dials and gauges right here. And to zero these, you're essentially going to be moving the numbers around, not necessarily the gauge, but the numbers, and you want to make sure that that's sitting right there on 0. And we'll talk a little bit more, as I said earlier, on how to use this in the further parts of the lab. But just to ensure that y'all understand, zeroing out these gauges, you're moving the numbers on the side, not the actual needle. Thanks for listening to this equipment. We'll go ahead and start digging into the lab now.
First thing we're going to do for this lab is we're going to weigh the empty tear can, because we're going to be using this later to try and get the moisture content from the soil. And then you're going to take your releasing agent and you're going to coat the inside of your mold in the collar, similar to the last lab. You're going to want to coat the inside, but not get it where it's completely soaking. And from here, we're going to do 25 blows for each lift. We're going to do 3 lifts, just like this last lab. But we're going to be using a different hammer. This one is spring loaded, So all you have to do is when you're trying to push it down is go far enough to where you break the spring, and that's going to apply enough force to compact the soil. So like I said, it's going to be 25 blows per lift, and then at the end of your last lift, it's going to be above the intersection between the collar and the mold. You're going to want it above that. So after your first lift, you're going to do 25 blows from the hammer. So after 25, you're going to take your ice pick and you're going to scarify the surface, just like the last slab. Then you're going to add your next lift of soil. And 25 more blows from the hammer. And after 25 of those, you're going to scratch up the surface again with the ice pick. And then you're going to add your last and final lift, ensuring that after compaction, it's above the interface of the collar and the mold. If not, we're going to have to start over. You're going to do another 25 blows of the hammer. Then the next step is we're going to be removing the soil sample from the mold. And the first thing you're going to do for that is you're going to take off the wing nuts from the top of this. And this base just slides right off. You can see that the mold comes in three parts. There's a top collar and then there's a little bottom collar. The bottom collar should stay there when you take this off. And then you're going to use this machine to take off the top lid. You can see these little grooves here. Those are going to correspond with the grooves on the bottom of the mold. You're going to slide that right up in there, and as you're doing so, you're going to ensure this top part is lining up underneath the collar on the top part of this collar here. And once you slide that all the way in there, you should be able to just lift up on this, and it will remove the top part of the sample. And then you're going to take this back out. You can see here is a little bit of soil protruding from the interfaces. To get a clean sample, we're going to have to cut these off. You got a variety of tools to do that. I think personally the easiest way is to just use the wire cutter. And you're just going to slide this down here until this soil is flush with the mold. Do that on both sides. In this next portion, you're going to have your partner come help you. You're going to place the mold back into the sample. And if my lab partner come over and assist me with this, he's going to take the spatula, Matt, and he's going to take the spatula and he's going to go through this and he's going to catch this mold as it comes out. So he's going to hold on to that I'm going to hold on to this, the whole apparatus to keep it from bending over. And then I'm going to use this lever and watching his fingers just slowly push the soil sample out. He's going to catch it on the spatula. And once he has that, thanks man, we can go ahead and weigh it on a small scale. We're going to do this quickly to prevent it from losing moisture. Once you have the weight, you're going to go on and move to the main apparatus. And you're going to place filter paper on the top and bottom of your soil sample. You're going to place it right in between here. As you can see, mine is too tall for this. So if this happens to you, all you're going to do is take this big lever and turn it counterclockwise to back the machine up off of it so that you can fit your sample in there. Try again. Still too tall. Still too tall. Still just a little bit too tall, but we are nearly there. Cut.
I mean, I was already gonna say, let's just edit this out.
Yeah, we can do like the 3 hours later thing from SpongeBob in there. It'd be pretty funny. Close. So close. There we go. All right. So once you get it actually to fit inside of the apparatus, what you're going to do is you're going to turn this knob clockwise to apply a seating load on this. So what that means is you're going to watch this top dial because that's measuring your force. So you're going to turn this slowly until you see this dial start to move, which means that it's actually on the soil. So we do this slow. And what this is doing right now is just compacting the soil and bringing this top portion down. And you can see that that dial started to move, which means that it's actually resting on the soil sample, which is what we want. So from there, we're going to go and zero our gauges. So for this force one, it's pretty simple. You just rotate the outside part until that zero is lined up on the needle. This needle gauge right here measures your deflection. So what you really want to pay attention to is that this prong right here, which is what is measuring the compression, has at least 3/4 of an inch of give for you to measure with. So if you have to raise or lower that, you can. Right now this one's good, so we're just going to leave it be. And then similar to that last one, just going to rotate the outer edge until that needle is lined up on the zero. You should be right there. At this point, you're going to use your lab partners to help you. What they're going to do is I would suggest having one person turning the knob, one person watching the force, and one person reading the deflection. And you're going to record these values on your data sheet. So you're going to rotate this clockwise to compress it at a rate of 1 revolution every 3 seconds, which is pretty slow, so be patient. So you do this pretty slow. And you're going to be measuring the force and the displacements as you go. And you're going to keep this up until your soil either fails or you reach a total deflection of 0.675 inches. So this will take a little bit of time, so be patient. But once it does fail, what you're going to do is you're going to take a sketch of your soil sample, and then you're going to remove it from the mold. And after it's filled, you'll have access to the middle of it, which is where you're going to take your moisture content sample from. So the tear can we weighed at the beginning of the lab, we're gonna open that up, take your teaspoon, get a little bit of that soil out of there, place it in the tear can, close the lid, weigh it on a small scale, and then place it in the area designated by your lab technician. And then you're going to clean up your mess, and you're going to repeat the process for the next 2 soil samples, which have different moisture contents. And that will conclude this lab. Ready, cut.